Hello, everybody. We are going to talk about two sections today. Hi, H and I. So H is pretty simple. What we're going to do, if you're paying attention to the box and whisker, you got the quartiles. So 25% less than that number, 50% or the median less than that number. Um, 75 percentile is the quartile 3. So we're just taking our data and we're cutting it in half, cutting it in half. So pretty cool. So we can make our box and whisker. This section just says, hey, let's look at two box and whiskers and compare them. So maybe this is what you're looking at here is the homework in year 9 and the homework in year 12. And an obvious observation is you got more homework as a senior, or you're spending more time. And that's really it. You're like, wait a minute. Yeah, you might be asked for what are the quartiles or what are the medians, but that's just understanding the 5 points of that make up the box and whisker. So I'm hoping that's not too bad for you. This would be quartile 1, this would be quartile 3, this would be the median, this would be the min, and this would be the max. So then maybe you compare that against, this. But basically what I want you to do is just lean back and say, it looks like year 12 has more. And maybe you say how much more, but that's really it. Um, So let's take a quick look at some data. So I'm not going to show you again how to find the 5 important points that make the box and whisker. Please use your graphing calculator to do it if you're asked to do it today. I think there's one question that kind of looks like this. So let's say you do that. Here are our 5 points for the old drug, the 5 points for the new drug. We create our box and whisker. This is called the parallel box and whisker because they're kind of like right next to each other. And then you kind of look at this and say, all right, well, what do I observe? Well, for the new drug, this number here is 9. So since that's the median, we could say that 50% of the time it is less than 9 seconds. Wow, that's pretty good. But the old drug, 50% of the time it was 10 seconds. I know it's only a second, but that's pretty significant. And look at this. You could say that 75% of the time the new drug took 10 seconds or less because I know that's the quartile and I'm really thinking about percentiles. So that's pretty cool. Man, not so good. Not so good on the old drug. We're bumping it all the way up to 12.5 seconds to cover 75% of the people. No good. All right. So that's all. It can be pretty obvious, but it's still a new mindset, like you're actually looking at the numbers and making decisions. Pretty cool. All right, so these are the type of problems, and look at that, I already stole one from you. Number 1 there. Number 3, ooh, can they be vertical? Absolutely, you got to turn your head a little bit, but I think you got it. And number 4, oh, you don't think you'd go without using your graphing calculator and being able to plug that stuff in. So good practice, only one, you're welcome. A few little answers for you. All right, now we're getting into the good stuff, I think. All right, the cumulative frequency graphs. So this is looking at the data, kind of looking at the cumulative data, graphing it, and then being able to pull off the median and the quartiles from that. So maybe there's a different way besides pushing one button in your calculator, um, and it's pretty cool. So a cumulative frequency polygon is when you actually connect these data points. I'll show you where the data points come from in a second with straight lines. But we want to kind of like get in the feel for it. And so we're going to use a nice curve to connect all our data points. And that's what makes this the cumulative frequency graph. Now I'm going to throw out, they use the word ogive. right here. And they're saying that's kind of like a frequency polygon with straight lines, but I've always heard it as the ogive curve, which is the cumulative frequency. So sometimes vocabulary can get in your way. Just don't want that to happen. All right, let's walk through a problem and see what happens. Um, we've already talked about percentiles. Um, I just want to, I kind of pushed it when we were just talking about the box and whiskers there. Remember quartile 1, quartile 2, also known as the median, quartile 3 is really talking about the how much data is from there back. All right, so really important to talk about that. Let's see what I mean. All right, we have a bunch of runners. I don't know where I'm going to go here. Let's go way over here. I'm just going to try to tuck myself way back in there. All right, so we have a bunch of runners. And just to kind of pull some data off of here, if I look at this 3, what it's saying here is that 3 runners scored a time that was less than 150 minutes, but greater than equal to 148. All right. So the first step of making a cumulative distribution is, an ogive curve or cumulative frequency graph, is to create a cumulative column. So remember, we have 8 here, we have 3 more here, so we really have 11 that have run less than 150. So it's cumulative. It's cumulative. So we had 8 people run under 148, 11 from 150 all the way down. So 20 people, we would say, run 152 or less. You see where I'm getting this? So we'll go ahead and finish this. 31, 43, 50, 55, 63, and 69 runners. Yeah. So anyways, there were 69 runners, and they all ran less than 176. All right, so now we have some data points. But what do you mean data points? They're for your notes. It's a nice little cleaner graph. All right, so there's a lot going on in this picture, and instead of doing it in a couple steps, kind of put it all there at once. So first, I'm going to bring your attention back to the table. All right, so here we have 11 people that have run 150. So the coordinate point that I'm going to plot is 150, 11. And just to talk about this one, we had 50 people run 158 minutes or less. Not exactly, up to, but not including 158. So those points come over here. So let's go ahead and plot 150, 11, and that's where this point comes in. 158, 50, 158, 50. So we're going to plot all these points, and then we're going to do our best to connect the points from point to point. And you can kind of feel like, oh, there's a little bit of curve, a little bit of curve, and so forth. And that is our graph. All right, so how do we use our graph to find stuff? All right, so let's start with the median finishing time. So the median time is the time where half the runners were faster and half were slower than that time. So when we talk about half the number of runners, we're taking our 69 runners dividing by 2 and we get 34.5. This is not the median. That means we have 34.5 runners to the left and 34.5 runners to the right. All right, so we got to go find this on the graph. And there it is. There's 34.5. Okay, 34.5. So what we do is we go along, and I like these arrows. They go along until you hit the graph, and then you come down on the graph, and right there is what you expect to be the median time. So maybe you estimate that to be, well, that's 156, 154.7 minutes. I don't know. Do you see that? I don't care. This is not about getting the exact value. It's about estimating using a graph. So please, if you show me this line and you hit this, and then you pull it down and you hit, yeah, graph paper probably pretty important here if you want to trust it. But then you kind of have to look at it, 154 here, 156, not quite 155. So I'd say 154.7. That is the median, 154.7. And of course, it's an estimate. All right, so let's look at the next one. I'm gonna slide over here because why not be in the graph? Be in the now. All right, so the number of competitors who finished in less than 155 minutes. So on this one, we of course change color. We go to 155. So that's 155. And then we go the other direction. So here we're traveling up until we hit the graph. And then we come over and see what number it hits. And they estimate it to be about 37. So 37 people ran at 150 minutes or less. All right. Do you see how you kind of go, if you want to start here, you're looking at the number of people, and on this side you're really looking at their times. So let that guide you of which way to start. Do you start on this side or this side? Let's try another one, and this is why we're doing this problem. A percentage of competitors who took more than 159 minutes to finish. Now this is a loaded question. There is a lot going on here. All right, so whoa, that was, all right. And I'm gonna need some room here, so maybe this might be enough. We'll see. All right, so on number 3, let's get this going. Okay, 159 minutes. So I'm gonna go to 159, go Alpine. I'm gonna travel up, I'm gonna travel over, and I get 52. All right, so 52 is the number of people that ran in 159 minutes or less. All right, so now we kind of have that number. The percentage of competitors took more time. So 52 did less. How many are left? So we take the total number of runners minus the 52, and we get 17. Now 17 is the number of runners that ran this thing in longer than 159 minutes. So when we talk about percentage, then we need to take 17 divided by 69, and we're going to get the percentage. And I have my rusty calculator here, and batteries are dead. Batteries are dead. So we can estimate 3, maybe around 25, 34. Yeah, it's really close to 25%. So I would say around 25%. But I would let you plug that in your calculator and get that exactly. Of course, I have it on the next slide so we can kind of estimate that. Time taken for a competitor who finished in the top 20% of the runners completing the marathon. This is tricky too. So if you want to be in the top 20%, what is that? Where is the top 20%? So 20% of the runners, we first need to do 0.2 times 69 runners just to see how many runners there are. And I'm going to estimate that to be about 14. I think it's 13.7, but we'll say 14. So we go to 14 and we move down and we find out that it is around 151. So the time taken by a competitor who finished in the top 20% is less than 151 minutes to be in the top 20%, which means you're in the top 14 people. Well, that's it. Do you see that? You just need to like try this and see what happens. I might do a little bit more for you. Oh, there we go. There's the solution. Let's see where we were. I said 154.7, so that's pretty close. Ooh, 20. I said 25%, 24.6%, 13.8. Yep, I took 14. That's cool. And there's the 151. Not bad. Not bad. All right. I did want to talk about this one. So sometimes people, have plotted the points. They've got their little situation all set up, and these things can sometimes be really really valuable to help you figure out those quartiles. So if there's 240 people total, the median is going to happen at 120. And I put the arrows on here to show you that you're starting here, you're coming down here, and whatever you get right there is going to be the median in that case. So let's say the top score was 13, the median score would be 5. In English, that means that 120 people scored a 5 or less, whether it it contains the number 5 or not, and 120 people scored higher than that. All right. Hopefully that helps. The quartile 3, the 75% helps, but you don't need these. You can just go, what is 75% of 240? And that's 180, and that tells you to go from over here, and that's going to give us our quartile 3. All right. Well, that's it. I did want to, here is just like the example. You're going to have to do the cumulative. You're going to have to graph it. It's a great exercise. I think you'll do great. Here is a graph, and I just, totally want to make sure you get this. Maybe look at one or two of these. Let's do A and C. So A, how many seedlings have heights of 5 centimeters or less? So here we're given the height. So here's at 5. So I'm going to go up 5 and then over. Maybe I say that's 9. Mr. Sayers, I said 8.738. Great. That's awesome. If you're in the ballpark, you're doing it right. So I'd say 9 have 5 or less. Okay, so we have a total of 60. So if I wanted to find the median height, what I'm looking for is what's the height that there are 30 below it and 30 above it. So why do I say that? Because median is exactly, where half the data lies. So here we go in this case. So in this case, we went that way. And in this case, we're going to go this way to find the median. So I'd say this is our median. So I'd say that is 7. There are 30 plants that are below it and 30 plants that are above it. All right. Why don't we, this has a lot to do with you guys. You're taking a lot of tests and you're like, oh, I was in the 95th percentile. I was in the 27th percentile. I was in the 5th percentile, whatever. Well, 90th percentile in this case means there are 90% of the people did worse than you. Okay, so if I'm a plant and I want to be in the 90th percentile, that means 90% of the population is below you. So 0.9 of 60 is 54. So you're saying there's 54 plants below you. So you go to 54, we better do this in red because it's super important. So we're going to do this in red. So 54 is right about here. And so I'm going to go like this, bam, and then I'm going to come down, bam, bam. So instead of saying it is a median or quartile, I'm just going to call it the 90th percentile. I could call the median the 50th percentile. Okay, so you can always interchange it. There's no special name for 90th percentile, except for in this case, pretty tall. So I'd say that's 9.8. So if I was 9.8 centimeters tall, I'd be in the 90th percentile, which means 90% of the people of the data are below me in this case. So you can see, like, if you take an SAT and you're in the 95th percentile, that means of all the people that took it that day, they're 95% of the people that took it are scored below you. Okay, so this is not where you want to walk in and say, I'm the 10th percentile. Woo! Because what you're saying is that 10% of the people did worse than you. So be careful. I guess you probably would say you're in the 10th percentile because you're probably not that good with the mathematics if that happened. But you're going to be fine. Even if you're in the 10th percentile. Got a good attitude, it will take you far. All right. Hopefully that's doable. Certainly use these notes. I think they'll help you. And good luck. Only 6 problems. So just take your time. And if you have to graph, please use graph paper. All right.